Today we're going to look at Chapter 9 now. We finished Chapter 8, we're going to go on to Chapter 9, and let me tell you about the relationship between these two chapters before we get started. In Chapter 8, remember we talked about confidence intervals. Our objective there was to say, what do you think the population mean is, or what do you think the proportion is, given what you found in the sample. The difference here is, although it's related, it's not exactly the same because in this chapter we're going to begin using what's called hypothesis testing. In hypothesis testing, we're given a value for the mean or for the proportion. Somebody tells us this is what we think the value is, and then you look at some sample data, and based on what you see there, you're going to say, yes, I think that is a correct value, or no, I don't think that is a correct value. So our objective is to test the hypothesis or the statement that we're given to find out whether we think it's true or whether we don't think it's true. Okay? Remember confidence intervals? They told us you estimate the value. With hypothesis testing, we're being given a value and asked, do you agree that this is the right value? So you've got to be careful when you read your problem to make sure which kind of problem you have. If it's a confidence interval problem, then you have to estimate it. If it's a hypothesis test, then we're just going to test the data to see whether it's close enough to say, yeah, I think that's probably the right value. Okay, hypothesis testing in Chapter 9 here is a very important section of material. The reason it's very important is because we're going to use this approach virtually the rest of the semester. So you want to make sure you understand how hypothesis testing works so that you get started on the right foot relative to it. And a good way of thinking about it is similar to a court of law example. In the United States, you know that individuals are presumed innocent unless it can be proven without a shadow of a doubt that they are guilty. So we're really beginning with a statement that says we think the individual is innocent. And the opposite of that statement is going to be what we call the alternative hypothesis. So we're going to use a term called the null hypothesis and the alternative hypothesis. We're going to use this same pairs of information or approach all the way through. Null and alternative. The null, and I'm going to give you a lot of hints here because one of the hard jobs you're going to have is deciding what is the null hypothesis and what is the alternative hypothesis. If the problem tells me, that would be pretty easy, but it's probably not likely the problem will normally do that. So you need to know what is the null and what is the alternative. In the court of law, the null hypothesis would be that the individual is innocent. Now we don't really know whether the individual is innocent, but that's what we assume while we do the test. So if the evidence is not strong enough, we're going to say, looks like the individual might be innocent. If the evidence is very strong in the other direction, we would say, looks like the individual is guilty. So the alternative, remember, is always the opposite of the null. If the null says the individual is innocent, the alternative would say the individual is guilty. So we'll write that down then. Now, how do we decide the answer to that question? How do we decide whether the individual is guilty or innocent? We look at sample evidence. Okay, and the sample evidence might be testimony from the lawyers, might be even testimony from the defendant, the person being accused, or other witnesses, or whatever else. And after we finish getting all that information, the jury has to come to a conclusion. They have to either say, we think the individual is innocent, or we believe the individual is guilty. They can't say at the end, I don't know. We won't let them out of the jury box until they come to a decision. So it's the same way when we do hypothesis testing. There's only two answers. Either we think the statement is true or we think the statement is false. Those are the two choices. So how do we decide which way to go? We look at sample evidence. Okay, so our sample data or sample evidence is the means by which we're going to come to a decision about the null hypothesis. Let me give you a simple example of kind of what we're trying to figure out here. All right? Let's say we're interested in the mean of some population. We want to know what is the mean. and somebody tells me that the mean equals 10. Now I'm going to examine a sample, and I'm going to look at the sample mean as my point estimate, remember, and if the sample mean turns out to equal 10, I'm probably going to say, well, it looks like the population mean is probably 10. But there's also a good chance that that sample mean will not equal 10. It could be other things other than that. And so the question is, let's say instead of 10 that the sample mean turned out to be 9.9. You'd probably look at that and say, well, that's pretty close to 10. Probably the mean is still equal to 10. But if we found that x bar instead of 9.9 was 100, we would probably begin to say, gee, I don't think the mean is equal to 10 because that doesn't seem like a very likely outcome to get a sample mean of 100. So the big question we're trying to answer here is how much difference between those two values is okay? How much is a big difference? And how much is a small difference? Okay, this is why we care about that question. If we decide that the difference between the hypothesized value, mu equals 10, and the sample mean, 9.9, is small, then what we're going to do is say, I think the mean could be equal to 10. So I'm going to say, I think the null hypothesis is okay. On the other hand, if x bar was equal to 100, and I thought the mean was equal to 10, I would probably say, gee, that looks like a big difference. So therefore, I don't think the mean is equal to 10. I would tend to reject that statement and say that it's not equal to 10. All right? So that's really the process that we're trying to use. Now, the hard part is it's impossible to tell simply by looking at the data whether the difference I observe is small or large. In fact, that's what we're going to spend most of the rest of the semester trying to answer, is that relatively simple question. Is the difference that I found between the sample value and the population value large or small? If the difference is small, we would attribute it to sampling error. If it is small enough and we attribute it to sampling error, then I'm going to say, I think the null is okay. If I decide that difference is too large or it's a big difference, then what I'm going to do is I'm going to reject the null and go with the alternative hypothesis. So in the court of law, I'd be saying the evidence is strong enough that I think the individual is actually guilty rather than innocent, and we have no shadow of a doubt, so it's a big enough difference, strong enough evidence that we're going to say, I don't think the individual is innocent, so we're going to call them guilty. All right, so that's really what we're doing here. Now the thing is, with different kind of data, we're going to have different types of tests we need to do in order to answer that question. Is this difference large or small? So we could have various types of tests. Each type of problem will be a little different because of the number of populations or the type of data or the kind of question we're trying to answer. But our basic objective is this a big difference or is it a small difference? If it's small, we're going to fail to reject the null. If it's large, we're going to reject the null and go with the alternative. So that's the concept behind what we're doing with hypothesis testing. Now let me give you a little bit more help here, I guess, in trying to figure out how these hypothesis tests work a little bit. Okay, remember I said the hard job often is going to be setting up the null and alternative. Remember, the alternative is always the opposite of the null. So if the null is mu equals 10, then the alternative must be mu is not equal to 10. It has to be exactly the opposite. The number always stays the same, the sign changes. Now here's some helpful hints. Equal sign will always be in the null, never in the alternative. Equal sign is always going to be in the null, never in the alternative. Now I could have in the null greater than or equal or less than or equal, but I can't have the opposite of that, which would be less than or greater than by themselves. Those have to be alternative hypotheses because there is no equal sign. Okay, now, how am I going to know what the null is and what the alternative is? If I'm talking about the null is going to be the claim. Somebody made a claim. They told us this is true. We think the mean equals 10, or whatever they told us. So that claim is going to be the null. I don't know whether it's true or not, but I always assume that it's true while I'm doing the test, just like in the court of law. I assume the individual is innocent unless the evidence is strong enough to convict them. All right, now some other words that will help you with null. Null means no or zero. Okay, so I could also use these phrases. No difference to describe what's going on here. No difference, no effect, no problem, and here's a key one, no change in policy. Whoops. No change in policy. That means keep doing whatever I've been doing. There isn't enough evidence to change. If I thought the person was innocent, I still think they're innocent. So we're not going to do anything to them unless the evidence becomes more convincing than it is right now. So no change in policy is what I'm going to do with the null hypothesis. Okay, my alternative hypothesis, which I often think is a little easier to set up first rather than doing the null first, is the question. Whatever the problem wants me to prove or to answer is going to be the alternative hypothesis. If they would say, is there enough evidence to say that the claim is not correct, then if it's equal to 10, that's the claim. If it's not equal to 10, that is the alternative. So under what conditions would we say the claim is not true? Answer is if we had the opposite of that claim, which is mu is not equal to 10. So whatever the question is, and I'll give you practice with this as we work problems, whatever we want to prove is the alternative. For me, it's often easier to set up the alternative first and then go back and do the null. But if the claim is real obvious to you and you want to just write it down, that's fine. But we'll give you practice doing that so you know how to do it. Okay, here's some other words that will help. There is a difference. There is a problem, or there is some effect as a result of what we've done. So therefore, if we rejected the null and went with the alternative, we would say there is now going to be a change in policy. That triangle means change. So there is going to be a change in policy. Under what conditions would I change policy? That's going to be my alternative hypothesis. If somebody told me the mean is 10, I don't believe the mean is 10 based on what I found in the sample, what's going to happen? I'm going to have to stop claiming the mean is 10. I'm going to have to come up with a new claim, which is I think the mean is something else. But I can't keep doing what I was doing before because I'm going to get into trouble. You know, if I'm claiming there's 10 ounces of green beans in the can and there's really 5 ounces in the can, I'm probably going to get sued. Now, if there's 12 ounces in the can, the consumer is not going to sue me, but the company may not be real happy. So I want to make sure that what the claim is actually true. And the way to find that out is by doing the hypothesis test. Okay, so that's the main idea, null and alternative, and they always go together. Okay, one of the other things we're going to do in answering the question, let's go back one screen here. Okay, we talked about a large and a small difference. Before or as we're working a problem, we're going to determine what do we think a small or large difference is. And then when we get our answer, we'll be able to say, yes, this is a large difference, that's why I'm rejecting, or no, this is a small difference, which is why I'm going to fail to reject. Okay, so we're going to begin to kind of illustrate that by using a common assumption of a normal distribution. Normal distribution, we know, looks kind of like this. And if it's a equal and does not equal kind of situation like that, we're going to have large differences out in each of the tail areas out here on the end of our distribution. This is going to cause me to reject if I'm out here, or reject if I'm over here. If I'm in the middle, in here, I'm going to fail to reject. Okay? So the question is, how far out are these critical value lines? How far away am I going to define as a large difference? Well, the answer is going to depend on how much confidence I want to have in my decision. And if I want it to be 95% confidence, remember, and I'm doing a z-test, which we've looked at before, then this area right here is going to be 1.96 is my critical value, minus 1.96. Anything above this, I'm going to reject. Anything below this, I'm going to reject. So these values are simply what? Standard deviations. 1.96 standard deviations above or below the expected value, which is right here in the middle, and that is mu. Okay? Now where does the 1.96 come from? The empirical rule. Remember, 2 standard deviations in either direction is going to be 95% of the values. So 95.5 is actually what it is. So this is almost that same number, 1.96, which corresponds exactly to 95% of the values. Okay, so this is going to give us then our rejection regions and our fail to reject region based on the level of confidence that we want to use. All right, now, the next thing we want to do probably is to talk about type 1 and type 2 errors. And this will help me to explain a little bit better why we set up the null and alternative the way we did. First of all, we just have to define. Type 1 error occurs when the null is true, the statement that's being made is true, and we reject it. So our decision is to reject the null even though the null is really true. That's type 1 error. The only way I can tell you to do that basically is to memorize it. There's not really another way to tell you. It is provided on page 276, so you can look at that to help yourself remember. But let's look at type 1, type 2, and then we'll show you how they fit together. Type 2 error is going to be the opposite of that. This occurs when the null is false and I fail to reject it. I say, it looks like it's okay to me, even though it really isn't okay. So null is false, and I fail to reject the null. That's called the type 2 error. Now, of course, we don't want either type of error. Neither type is very desirable, so we're going to make a chart that shows you kind of the possible combinations here. This is found on page 276 as well. We have the actual situation, or the truth, is up here. Okay, and then we've got our decisions over on this axis. Now, there's only 2 possible decisions we can make. We can fail to reject the null or do not reject the null, and reject the null. Those are the 2 choices. All right? And of course, it would be easy to make that decision if we knew whether the null was true or not. But we don't know that, so it's possible we could make mistakes. Here, possibility is the null is true. The other possibility is the null is false. Okay, so if the null is really true and we fail to reject it, or don't reject it, we have a correct decision. If the null is false and we reject it, we also have a correct decision. That's where we're going to hope to be most of the time. However, we're not always going to be there because we can make type 1 or type 2 errors. If the null is true and we reject it, remember that's called type 1. Type 1 error. We use the symbol alpha, Greek letter alpha, to refer to our type 1 error. Okay, type 2 error occurs up in this cell. And what's happening up here is, and that's called beta, is the null is false and we fail to reject it. Okay, so those are the 2 types of errors that we can commit. And again, we just need to pretty much memorize that because there's no real way to tell you other than that. But these are the definitions for those 2 approaches. All right, now, let's think about what's going on here. If I reject the null, well, in any problem that I start out with, the problem is going to give me the level of alpha. It's often 0.05. It could be 0.01, could be 0.10. One of those 3 values is what it's likely to be. Could be something else. If the problem doesn't tell me anything else, always assume 0.05. If the problem uses another value, then use the other value. So what I want to know is, let's say alpha equals 0.05. I'm going to put that in this cell of the table. That means I'm willing to live with a 5% chance of making an error. If I reject the null, I'm in this row now, if I'm rejecting the null, then I could be committing a type 1 error, or I could be making a correct decision. The probability of a type 1 error is 0.05, which means 5%. So the probability of being correct is 95%, at least. Okay, so 1 minus, or 100% minus 5% gives me 95%. That's where that number came from. So if alpha is 0.05 and I rejected the null, there's a 5% chance I could be making an error. There's a 95% chance that I could be making a correct decision. That's real useful information because that tells me when I reject the null, I can have a high level of confidence that I'm making the right decision, 95% for instance. Okay? Now if I don't reject the null, I've got a different situation because if my decision is up here, do not reject, I might be making a correct decision, or I might be making a type 2 error, which is called a beta type error. Now, type 2 error, we don't set the level for the type 2 error. It is determined by the sample size and the size of the type 1 error that we have. So, if this value is 0.05, the type 2 error is going to be determined by the sample size and the size of my type 1 error. The problem with the type 2 error is, remember the definition, the null is false, but I failed to reject it. So, if the problem told me that mu equals 10, and the true value for the mean is really mu equals 9.99, it's not very likely that I'm going to reject that null. I'm probably going to say it looks okay to me, even though I should be rejecting it because it's not equal to 10, it's equal to 9.99. So the probability then of a type 2 error is going to be quite high if the value of mu that's hypothesized is close to the actual value of mu. If there's a big difference between those, like if the real value is 100 and I thought it was 10, I'm probably not going to make a type 2 error very often. But if those values are close together, my chances of making an error are very high. And the problem with a type 2 error is, since the statement is false, I don't know what the true statement is. I don't know what the real mean is, for instance. So I don't know what the probability of a type 2 error is. If I do not reject the null, I might be committing a type 2 error, or I might be having a correct decision. But the way I look at that is, if I'm not rejecting the null, then I have 0% confidence. Okay? The reason is because I don't know what the probability of a type 2 error is. If I reject the null, I can have a high level of confidence. If I fail to reject the null, I have 0% confidence. So, in a statistical sense, it's better to reject the null than it is to fail to reject the null because that's going to give me confidence in my decision. All right? So, that's some background information. Now, we need to try a problem to make sure you're kind of getting the idea of what these type 1 and type 2 errors are all about because it's easy to get confused. I'm going to look at problem 9.13 and 9.14, which are found on page 277. Okay, let's read the problem and see if we can figure it out. In the U.S. legal system, a defendant is presumed innocent until proven guilty. Consider a null hypothesis that the defendant is innocent and an alternative the defendant is guilty. So let's write down what we know here. 9.13, defendant is innocent. That's my null. And my alternative hypothesis is defendant is guilty. Defendant is innocent or guilty. Those are the two options. Okay, so let's keep reading. A jury has two possible decisions: convict the defendant, which means reject the null, or don't convict the defendant, do not reject the null. Explain the meaning of the risks of committing either a type 1 or type 2 error in this example. Okay, so let's say type 1 is what I want to talk about first. So type 1 or alpha type error would occur if what? Now we got to go back to the definition. The definition is I'm going to reject the null when the null is true. So the truth is what? Go back to the null. The defendant is innocent, but I'm going to say that they're guilty. So my type 1 error is going to occur if the jury says that the defendant is guilty when the truth is that they are innocent. That's a pretty serious problem, you know. We don't want to send somebody to jail or something else if they didn't commit the crime. So that's why we like to specify the level of the type 1 error most of the time. So what we're saying here is the jury is going to say that we think the defendant is guilty, so they're rejecting the null when they are in fact innocent. So that's going to be a serious mistake. We want to protect ourselves against that, so we probably want a fairly low level of alpha to make sure that that doesn't happen. The problem is when I reduce the level of alpha, other things equal, the probability of beta goes up. Let's talk a little bit about the relationship between alpha and beta, type 1, type 2 errors, because I probably will have some objective questions relative to that on your exam. Okay, if I want to reduce the probability of a type 1 error, if I keep the sample size the same, the probability of a type 2 error is going to go up. If I reduce the probability of a type 2, keeping the sample size the same, probability of a type 1 error is going to go up. So there's a trade-off between the two of them. If I want to reduce the probability of both type 1 and type 2 at the same time, what I can do is increase the sample size. If I do that, both of those errors are going to go down. Now listen carefully to what I'm going to say next. If I want to eliminate the probability of a type 1 error, and I don't want to use the whole population, I can do that. The way I can do that is by never rejecting the null. If I never reject the null, I'm never going to have a type 1 error. But I'm going to have a lot of type 2 error because I'll be failing to reject all the time, even though sometimes I should be rejecting. If I want to eliminate the probability of type 2 error, all I've got to do is reject all the time. But then I'm going to have a lot of type 1 error. So ideally, we'd like to make correct decisions, which is hopefully what we're going to do most of the time. But if we try to reduce one, the other one's going to increase as long as the sample size stays the same. Okay, so we looked at the type 1 error. That is when the jury says the person is guilty when in fact they're innocent. What would be a type 2 error in this situation? Well, go back to the definition again. Type 2 error, which is beta, would occur if the jury says, remember type 2 error says, we fail to reject the null when the null is false. Okay, so the null is false. What does that mean? That means the defendant is guilty. That's the truth now. Defendant is guilty, but the jury says that the defendant is innocent. That's going to be called the type 2 error. Does this ever happen? Sure. If the evidence isn't strong enough, the jury is likely to say the person is innocent even though they are really guilty. But we'd rather, in our system, we'd rather let them go unless the evidence becomes stronger than to convict them when in fact they didn't commit the crime. Of course, this is becoming a little easier with DNA testing, but the idea is still important. Type 1 and type 2 errors and how they relate to this. Okay, let's look at then problem 914. That's similar to the last one, except now in some judicial systems, like France, the defendant is presumed guilty until proven innocent. So what's going to happen is the null and the alternative are going to be changing. The null hypothesis now is going to say defendant is guilty, and the alternative is defendant is innocent. So those are reversed from what they were before. All right, now let's see what the question was again. So that's how the null and alternative differ. What are the meanings of the type 1 or type 2 error then? Well, if I'm committing a type 1, alpha type error, what am I doing? I am saying that I'm going to reject the null. So the jury then is going to be rejecting the null. What does that mean? Saying that the person is innocent when the truth is that they are guilty. Defendant is guilty. Okay, so this is now the type 1 error. The jury says they're innocent when in fact the defendant is guilty, and the type 2 error is going to be the opposite of that. That will occur when, remember the definition says, type 2, we fail to reject the null, so what we're saying is we think that the defendant is guilty when the defendant is really innocent. Okay, now neither of these are very good, but in our system we would prefer to let the person go than to convict somebody who has not committed the crime. In the second case, 914, we're assuming they're guilty, and unless the evidence is strong enough, we're going to put them in jail or give them a penalty. So it's a different system, and therefore the probability of the type 1 or type 2 error is going to be different, or the meaning of it is going to be different in each of those two systems. Okay, we're finished with section 1 of chapter 9.